Welcome to the video on graphing with logs, and with this one we're just going to try to sketch a few graphs of logs here. And to start out, what I want to do is basically just see how an equation would be written and how that would affect the graph, and we'll do some graph shifting and things like that once we got a basic log graph down. Alright, so what I want to do is to take an equation that looks like this, say y equals the log base b of x, and just get sort of a basic graph of that off of this guy. So if we just take y as log base b of x, then what should that look like? So remember, this base is sort of the same as the exponential. So if we change this to exponential form, let's go and see what this would look like. So this would look like b raised to the y power equals inside the log, which is the x. Alright, so b raised to the y equals that x inside the log. Alright, so remember, logs always equal the exponent, so there's that y up there. So this looks a lot like our exponential equation, except for the x and y are switched here. And so what our graph is going to look like is basically sort of like an exponential, except the x and y are going to be swapped. So let's go ahead and take a look at a few points here. One point that is always going to be on the log graph is the point right here at 1, 0. Alright, so we'll go and put a dot right there at 1, 0. So this point 1, 0 is always on the graph. Alright, unless I've shifted it up or down or left or right or something like that, that will be a point that's on there. Just because the log base b of 1 is always equal to 0. So that's using that property right there, that log base b of 1 always equals 0. Alright, so that'll be a point that we always go through. Another thing that I am going to have is an asymptote. So with exponentials, we usually have that horizontal asymptote across the x-axis. Now we're going to get this vertical asymptote right through here down along the y-axis. So this is going to go something like this down through the y-axis. And I'm putting some of this in by hand just so you can see how we sketch these out instead of how it looks on a computer or something like that. So just what a sketch would look like if you're doing it by hand. Alright, once we got that down, now we can go ahead and try to find some other points. So if you want to pick some other points, you can, but if our base is bigger than 1, alright, so b bigger than 1, our graph is going to look something like this. Alright, so we'll get this sort of log shape right there. And if you think of it in terms of exponentials, this should make a little bit of sense right here. Alright, so with exponentials, as you go further away in the positive direction, the exponent gets bigger. So we just get further away from the axis. Same with the log here. So as this gets further out in the positive direction, I'm just going to get further away from that y-axis this time instead of the x-axis. As I get in the negative direction here, I'm going to get closer to that asymptote. So in the negative direction, I get closer to the asymptote, only this time it's the y direction instead of the x direction. Alright, so because all x's and y's are swapped on this log graph. Alright, so that's our basic graph of what that would look like. And this is going to be if b is bigger than 1. Alright, so this is if b is bigger than 1. If our b is less than 1, then we'll just get a reverse. So let me just go ahead and sketch a quick one of that down here. And we'll do a few more that are a little more careful with numbers. So if b is, we'll get that point right there at 1, 0. Alright, so still get that point. Still get the asymptote that goes right there through y is 0. Alright, so we still get that y equals 0 asymptote. That's right there. Only this time now we're going to get one that goes toward the asymptote in the positive direction and away from the negative direction. So something like this. Alright, so that's what our log graph would look like if b is less than 1. Alright. And then just like exponentials, we don't use negative bases. Logs, same thing, we don't use negative bases. So they cause complex numbers. It's not that you can't do it, but you do get complex numbers which won't give us anything for our graphs. So we're just going to stay away from negative bases for these guys. Alright, so those are the basic graphs that you should be looking at when you do these, and we'll go ahead and do a specific one right here. So let's go ahead and try a specific problem. Alright, so here's one with y is log base 2 of x minus 3. Alright, and this one we'll look at has the basic idea of just graph shifting. And so this will look like log base 2 of x with a shift to the right. So remember, this is going to shift to the right 3 units. Alright, so we'll go and put that in. So shift to the right 3 units. Alright, so that means that a couple things are going to shift. One is the asymptote. Alright, so the asymptote that used to be at y is 0 now shifts to the right 3 units. Alright, and so we just get an asymptote that runs right through y equals 3. Alright. The other thing that happens is now that point that used to be 1 to the right of that asymptote at 0 is now 1 to the right of that asymptote at 3. So it's right there at 4, 0. Alright, so there's that point right there. And then the rest of this is just going to look like your basic log graph here. So if you wanted to plot more points, you could. Most of these, though, we are just trying to find a sketch. Alright, so and that will continue toward the asymptote forever down there in the negative direction. Alright, so that is basically what I'm looking for right there. If you wanted to go and put in a few x values or make an xy chart to try to plot more points, you could, but this is the basic thing that I'm looking for right here. Alright, let's see how that looks on the calculator, because there is one important point that you need to see on the calculator. So we'll go ahead and type this in. So this is going to be the log base 2 of x minus 3. And the first thing you need to know about that is that if I'm going to write in, let's go ahead and write it over here real quick, this log base 2 of x minus 3 on the calculator, I don't have a log 2 button. So what I have to do instead is use that change of base. So this would be just the log of x minus 3 divided by the log of 2. Alright, so I'll go ahead and put in log of x minus 3 divided by that log of 2. Alright, and that's what I'll put into the calculator. Alright, so when I look at that, now let's see what we get. So in the y equals, go ahead and clear some of these out. We'll go ahead and put in this log of x minus 3. And again, you can use log or natural log. It doesn't really matter for these problems. So log of x minus 3. And then divide by that log of 2. Alright. Again, make sure you close your parentheses of your log so you don't put in the wrong thing. And hit graph, and it should look something like this. Alright, which it does. It goes through that point right there at 4, 0. Climbs kind of slow as you go to the right. But right here is one difference you need to be aware of, and that is your calculator will always cut off this log. So it looks like it ends right there around between -2 and -3 in the y direction. But really that's just calculator error. It doesn't have enough space to be able to draw the rest of that out. If I were to actually zoom in, it's worth seeing on here. So if I were to zoom in around that endpoint, you'll just see that it's not really an endpoint. It does continue on. So even if I come right down here to the end and hit enter, right there I will see more of the graph. So even though I was right at the endpoint, we are seeing a little bit more than where I zoomed in at. So you can keep doing that, and it'll keep showing you a little bit more as you go. The reason for that is when it makes its table of values to plot, a lot of times it just runs out of space because it's so steep going down vertically. Alright, so one thing that you should have that the calculator doesn't have is this arrow at the end of your graph as you head down toward the asymptote. So just want to point that out. Alright, let's go ahead and try another one of these with a little more shifts. So we'll go ahead and try that one next. Alright, so on this one we'll go ahead and graph y is -2 plus the natural log of x plus 1. And remember, a natural log is just a log with a base e, but this one we do have built into the calculator. So this one is going to be shifted down 2. Alright, so that -2 on the outside of the log means I'm going to go down 2 when it's being added. And the inside of the log, the x plus 1, this is just going to be 1 to the left. So this is down 2 and 1 to the left. Alright, so we'll go ahead and put a couple pieces in there. So remember, our basic log graph on that is going to look something like this. I go through the, right here and go up to the right, something like that. So with any base bigger than 1, including the e, e is around 2.7, we're going to have that sort of shape. So this asymptote that's usually at 0 is now going to go to the left 1. Alright, so there's that guy, the left 1. And the point that we used to have at 1, 0 does the same thing. It goes to the left 1. Alright, so that would take it right there to 0, 0. But not only does it go to the left 1, it also goes down 2. So we'll have to go down 2 to the negative 2 right there. Alright, so there's that point. And then the rest of it is the same sort of shape. So this shape right here is going to do the same sort of thing. Grow kind of slow as we head out to the right. And that point right there is the turning point. That is where we start to head down toward that asymptote. So looks something like that. Now the specific x-intercept, if you wanted to look for that, you could use your calculator to try to look for that. And we'll probably do this one on the calculator anyway, but that one, if you actually want to find that 0, you should look for your calculator on that one at this point, since we haven't gone through really trying to solve for these guys inside the logs yet. So that's something that we'll be doing here in the next section coming up. But for right now, you can just eyeball that with your calculator. Alright, so let's go and see what the calculator looks like on that one. So if I do a regular zoom now, zoom 6, alright, it gives me standard zoom, and if I go to the y equals, change my function. Alright, so now this is going to be negative 2 plus that natural log, which is right by the 4 there, of x plus 1. Alright, so that was my function. And now I'll go ahead and hit graph, and it should look something like the graph that we just drew. Alright, so if I hit graph, looks something like this. So notice there's that point right there at negative 2, and then I'm coming down toward the negative 1. Again, it cuts it off, but you guys should continue it down toward the asymptote. And it looks like I crossed a little too early. I should be crossing somewhere around 6 or 7, somewhere in there. So if you wanted to, draw that growing a little bit slower out that way, that would be fine. But if it's asked for a sketch, we're not going to be too picky about that just yet. We'll get a little more accurate as we go. Alright, so let's go ahead and see what we get for a couple other questions here, which are domain and range. Alright, so domain, what this is asking for is all the valid x values. Alright, so if I look at the domain of an exponential function, these are all the x's that I can use. And in this case, I can't use the asymptote. There's no point on the asymptote right there. So I can't use that point at negative 1, but I can use anything to the right of that. So we'll say the domain is negative 1, alright, all the way out to infinity. Alright, so there's the negative 1 to infinity. A lot of times they'll also ask you for the equation of the asymptote. So the asymptote equation in this one, remember, a vertical line is always a y equals. Alright, so this is going to, or x equals, so this is going to be the line x equals negative 1. Alright, so basically whatever would make the inside of that log 0, that's where your asymptote is going to be. So right at x is negative 1. So there's the asymptote, there's the domain, there's a sketch. Those are often 3 things that they ask whenever you're graphing these functions. So go ahead and try the homework, and let me know if you have any questions.